Electroplating is the first stop at the pressing plant. The foil is brought here from the cutting studio to be prepared for electroplating. To improve contact and conductivity, a piece of foil is removed from the back around the center hole. Afterwards, the central area of the disc is roughened so the label won't tear or slip during pressing later on. Then the foil is rinsed with demineralized or deionized water. Rinsing is very important to remove unwanted residues and other substances from the foil. Then the foil is dipped in a degreasing fluid to remove or at least reduce the foil's own gas emissions and any finger marks. The degreasing fluid mainly consists of potassium hydroxide. Afterwards, it's rinsed again. The next step is necessary to enable the formation of a cohesive aquatic monolayer on the foil. The foil is then wetted in 3 different baths and so prepared for silvering. The timing is very important here. If the foil is left in the preparatory solutions for too long, the background noise of the vinyl might increase. If it's taken out too early, however, the record might crackle. Rinsing is very important after every stage, because some new residues accumulate on the foil every time. In the so-called silver plating cabinet, the foil is now attached to a turning knob. A small amount of wetting agent is sprayed onto the surface once again to prevent the surface film from breaking during the silvering process. After that, a mixture of silver solution and reduction solution is applied. This mixture reduces itself to a layer of silver film on the foil surface, less than 1 micrometer thick. Without the preparatory steps, the silver film would develop much more slowly and wouldn't be so consistent, which would lower the sound quality dramatically. Here's an example of how it would look if the foil wasn't correctly pre-treated. There is no cohesive monolayer on the foil surface, and the water forms beads. So let's get back to the correctly silver-plated foil. The residues on the back are removed with a sponge before the foil is rinsed again. Cleaning is very important because undesired substances may compromise the galvanic bar and make it unsuitable for the next step. The foil is now brought to the so-called pre-electroplating. Beforehand, a rubber ring is put round the edge. This will ensure that the nickel coating, which is developed during the electroplating process, can be easily separated from the foil. Now the foil is dipped into a nickel sulfamate solution. An electrochemical process takes place. Here the cage with the nickel balls inside is the positive pole, called the anode. When subjected to DC current, the nickel ions migrate to the silver plate, the cathode in this case, and accumulates as a metallic nickel plate. In the pre-electroplating bath, relatively low amperage and temperatures are used. With higher amperage, the nickel plate can generate internal mechanical tension, which would possibly distort the groove of the foil surface. The foil now remains at the pre-electroplating for approximately 1.5 hours. After that, it's put into the main electroplating process, where the nickel plate grows to its final layer of thickness, which is about 200 micrometers, 0.2 millimeters. In the main electroplating process, high temperatures and amperage are used. Therefore, the nickel accumulates more quickly than in the pre-electroplating process. The layer thickness is always a result of time and amperage. When electroplating is finished, the newly developed nickel plate is separated from the foil and is now called the negative. Since no further replicas can be made from the foil, another step is necessary. The complete electroplating process is repeated with the negative. At the end of this process, the positive is developed, the so-called mother. From this mother, several negative copies are produced, which are also called sons or stampers, and are used as pressing templates.